All right, guys, so here in 7.2, we're going to learn a new set of identities. So we're going to add that to the identities you already have, like the reciprocal and the quotient, Pythagorean, etc. All those basic ones we're going to keep using as we go into this next section, but we're going to add more identities to that. So I'm going to give you the identities, and then I'm going to work a couple problems. These identities hold for, there's separate ones for sine, cosine, and tangent. So I'm going to start with sine. We're going to do some problems using these sine identities. Then I'll do cosine, and then I'll do tangent. So let's start with sine. So these are called sum and difference identities. And these are identities that are going to tell me how to find the sine of two angles added together. So that's why this is a sum identity. So this is sine of A plus B. And you guys, these are not just distributive property here. So I want to make sure that you don't get caught into doing that. It seems easy, right? You just do sine A plus sine B. That would be amazing if it worked out that way, but it doesn't. Guys, so sine of A plus B is going to be the sine of A times the cosine of B plus the cosine of A times the sine of B. So I have sine A cosine B plus, and then switch it, cosine A sine B. This is how I find sine of A plus B. The difference identity for sine, if I want the sine of A minus B, it's very similar. It's going to be sine A cosine B minus cosine A sine B. So, very similar. Notice the sign difference. This one has a plus, this has a plus, this has a minus, this has a minus. That makes sense. Okay, so let's work some examples. All right, so the first example I'm going to do is I want to find the sine of 75 degrees. Now you might say, oh, well, isn't that pretty easy? Can't I just stick it in my calculator? Absolutely, guys. But our goal is to find exact answers for the angles we look at today. So we know that we have those special angles on the unit circle, and those have exact answers. Like if I look at 30, I can go and say, oh, the sine is 1/2. And that's an exact answer. I didn't have to use my calculator. But as of right now, any angle that's not on the unit circle, the only way I have to really calculate it is to put it in a calculator. But I'm going to use these identities to help me find the exact value of this without a calculator. So I look at 75 and I say, well, that's not on my unit circle. Could I write 75 though as either the sum of two other angles or the difference of two angles? And honestly, you could use either. I'm going to use a sum here. And you guys, when you think about the A and B that you want to use, make sure that those are angles on your unit circle. So instead of saying the sine of 75, I'm going to say, well, that's equal to the sine of 30 plus 45. So guys, 75, 30 plus 45, these are two equal statements. I've just written this, I've broken up the 75 into two angles that I do have on my unit circle. Now, I can use this line. I say, okay, this looks like sine of A plus B. So I'm going to use this first identity. So the sine of A plus B is sine A cosine B plus cosine A sine B. So I have it all written out like this. These values, sine 30, cosine 45, and so on, those are on my unit circle. So all I have to do is look them up, reference them, put them in here, do some multiplication and some addition, and I have found an exact answer for the sine of 75. So let's do that. You guys, what's the sine of 30? Well, that's 1/2. So notice this is sine 30 times cosine 35. So I do the 1/2 times cosine 45, that's root 2 over 2, plus cosine 30, what's that? Well, that's root 3 over 2, times the sine of 45, root 2 over 2, And then on here, you guys make sure that we multiply these two terms together before we do any addition. And you guys, the multiply part is easy. How do I multiply fractions? Straight across the top, straight across the bottom. So on the top, I have 1 times root 2, so I have root 2 over 2 times 2, so 4. Plus, you guys, how do you multiply two roots together? Well, as long as they're the same root, so they're both square roots, I can just multiply under the root and put them together. So root 3 times root 2 is root 6. And then there's another 4 on the bottom. You guys, these both have 4s on the bottom, so let's go ahead and put these two fractions together. So when I'm adding fractions, I know that it's going to be a single fraction with the 4 on the bottom. I can't add roots together, so I just have to write this as root 2 plus root 6 over 4. And it doesn't look super clean, you know, as far as answers go, but this is exact, and that's what we're looking for. You could put that in your calculator and get a decimal, but if you're going to do that, you might as well just put that in your calculator, right? So what we're looking for is the exact answer. So on this one, for the sine of 75, I got root 2 plus root 6 over 4. Let's do the sine of a difference. So we used the sum identity on that one. We did 30 plus 45. Let's do one where we use the difference identity. So what if I wanted the sine? And you guys, sometimes these can be negative. So I'm going to do a negative. I'm going to look for the sine of negative 15. Now, there's definitely a couple ways I could go about this. I could say, oh, sine's an odd function. I can pull the negative out and just look at 15. You could do that, but there's a lot of margin for error there. When you pull that negative out, when you separate it into two terms, you'd have to make sure the negative distributed to every term as you go. And you guys, what I would suggest on this, because we do have both the sum and difference identities, I would just use a difference. I can find the difference of two positive angles that make this negative 15. So let me show you what I mean there. So what if I did the sine of 30 minus 45? So you guys, I've got two positive angles here, 30 and 45, just like I had last time, but I have a minus in between. And 30 minus 45 is negative 15. So the way I'm dealing with the negative today on these is just to find a difference of two positive angles that give me that negative value. So you guys, I have the sine of 30 minus 45, looks like sine of A minus B. So it's going to be the sine of A cosine of B minus the cosine of A sine B. So it looks almost identical to the one we just did, except there's a minus here. All right, so these are the same values we got before. We have the 1/2 root 2 over 2 minus root 3 over 2 and root 2 over 2. You guys, multiplying those fractions together, I get root 2 over 4 minus root 6 over 4. So a very similar answer with this being the difference, right? So I get root 2 minus root 6 over 4. So you guys notice your answer is really close as far as the values go. When you're doing these, when you're doing both sine and cosine of sums and differences, your answer is always going to be some combination of a root 2, a root 6, and a 4 on the bottom. The signs on the 2 and 6 are going to change, but you guys, if you get any other values when you're doing the sine and cosine problems today, something's gone wrong. You got to have a root 2, you got to have a root 6 over 4 in some combination there. All right, so those are two sine examples. Now, both of those I did in degrees. You're going to have some questions today that are in radians. And you guys, radians are a lot harder to break up. And I'm going to give us the cosine identities. And one of our cosine examples will be in radians. And I'll tell you how to deal with that. Okay. So let's talk differences. So you guys, the cosine of a plus b looks like this when you work it out. It's going to be cosine a cosine b minus, so take note of that on the cosine problem where this is a plus, this is a minus sine a sine b. The cosine of a difference, so the cosine of a minus b, looks very similar. It's going to be cosine a cosine b plus sine a sine b. So just like the sine, it has some things in common, right? The actual terms here are the same for both the sum and the difference. The only change here is the sign, and notice the signs are different for cosine. If this is a plus, this is minus. When we made it a minus, this turned into a plus. So let's use a cosine. So you're going to have some like this that are going to be in radians, you guys. So couple of different ways you can go about this. You can leave it in radians. You can separate this as the difference of two angles in radians. The hard part that we hate about radians is that the fractions, right? I don't want to think about how fractions separate apart. I will show you how I would do it, but then I'm going to give you a way that you might like better. You guys, if you want to stick with the fractions, if you say, hey, you know what, I need to work on getting used to radians, I might as well do it here, or just brushing up on your fraction work, this is how I would do it. You guys, I've got 5 pi on top. I'm going to think about breaking that 5 pi apart. So it's going to be something plus something or something minus something. You guys, the way I would break this one apart is instead of just saying 5 pi over 12, I would write this as 2 pi over 12 plus 3 pi over 12. So notice all I did was I broke apart the 5. And what do I have here now? Well, what is 2 pi over 12? Reduce it, you guys. Isn't that just pi over 6? What about 3 pi over 12? Reduce that, guys. Isn't that just pi over 4? And you can see that when we broke it up here, I was really breaking it up into two angles that are on my unit circle. So it's not that bad, but if you really don't like fractions, there is some, you got to know how to break it up. You got to know how to reduce it. What's another option, guys? You guys, if you don't like radians, can't you just convert it to degrees? Your answer has nothing to do with degrees or radians, right? Your answer is just numbers. So I don't care either way. You guys, you could take the 5 pi over 12 and work it out. How do I convert from radians to degrees? Don't I do times 180 over pi? And you guys do some canceling, all that. You guys, you're going to end up with 75. So you guys, sure, take it in radians, break it up, reduce it. I can see my special angles here. Or if you don't want to do any of that, take the radians, convert it, find the angle you're looking for in degrees. So either way you want to work it. Notice that if I had changed it to degrees, we got 75 here, it would have been 30 plus 45, right? Well, isn't that what I still have here in radians? Isn't this 30 and this is 45? You're doing it the same way. Either way, just depends on what you like to do. Okay, so again, by all means, convert it to degrees if that makes it easier for you. I'm going to leave it like this because once we're past this point, we're just working with numbers anyway. So you guys, this looks like a cosine A plus B to me. So 30 plus 45, or the radian version I have here. So cosine A, cosine B, A plus B, guys. Remember there's a minus here. Minus sine A, sine B. And remember, as you use these, you might come to memorize them. You don't have to. These are things you can add to your identity sheet that you can always reference. I know these like the back of my hand, but I also teach them year after year. So don't be concerned with that. You guys, the cosine of pi over 6, or if you're in degrees, cosine of 30, that's root 3 over 2. cosine of pi over 4, or 45, that's the root 2 over 2, minus sine 30, or sine pi over 6, that's your 1/2, the pi over 4 again, that's root 2 over 2. So you guys, I know how this is going to turn out, right? So let's see what I'm going to have here. Here's going to be my root 6 over 4. Then I'm going to have minus root 2 over 4. So this one's going to end up being root 6 minus root 2 over 4. See, just another combination of those three values, root 2, root 6, and 4. So we got that. We used a sum on that one, and it was in radians. I'm not going to do a difference on the cosine. You know how it works. It works just like the difference did on the sine. Sometimes you just might want to subtract two angles instead of adding them. And it's always up to you. The way these work, no matter what angle you're given to start with, you could add two angles to get there, or you could subtract two angles to get there. So it's just up to whatever comes to your head first when you start working the problem. So we've got the cosine. You have these written down. You guys, things about cosine that are different than sine. Remember with sine, it was sine, cosine, cosine, sine. In the cosine ones, terms are lumped together. It's cosines, sines. And then remember the difference here in the sines. Okay, so let's talk about tangent. Okay, so tangent identities are a little weirder, which is usually the case. Okay, so I want to find the tangent of A plus B. These aren't our favorite things to do. But here we go, right? Tangent of A plus B is a fraction. It's going to be tangent A plus tangent B over 1 minus tangent A tangent B. So it's, like I said, not as pleasant. It's a fraction. But still, it's just an identity you have to reference. All you have to do is plug in values. Tangent A minus B, just like the sine and cosines work, it's going to look just like this one with some sign changes. So you guys, if I want to find the tangent of A minus B, I do tangent A minus tangent B over 1 plus tan A tan B. So we're going to do an example of a tangent next. So in this example, guys, I want to find the tangent of negative 13 pi over 12. So I want to make sure I do more challenging ones with you, so when you find them in your homework, you're not blindsided because I've done all easy problems, right? So you guys, first of all, this is negative, and it's radians. So 13 pi over 12, if you don't know what it is off the top of your head, do a quick conversion. Anytime you have a negative with the fractions, I think it is actually easier to convert it to degrees. So that's what I would suggest you do. Even if you like to leave it as radians for some of the problems, even I would convert this one if I didn't know these radian values. So you guys, I'm going to take 13 pi over 12, multiply it by 180 over pi, do some cancel here, and I get 195. So you guys, I could rewrite this as the tangent of negative 195. All right, so it's still a little bit more complicated than the ones we've done. We've been working with smaller angles like 30 and 45. So I need to find a way to find negative 195. Remember, you don't want to use negative angles in your A and B, right? You want those to be positive. So think about a way to write maybe a difference of two angles that are on your unit circle that would add up to negative 195. When I see negative 195, what I think about would be this. And you guys, it might take you some time to find the right combination. Well, there is no right combination, to find your combination that you want to use. But what I'm going to use is 45 minus 240. That'll get you to negative 195. So notice my two angles are positive. They're on the unit circle. All I have to do is put them into my identity. I think I'm going to do it up here because we're getting a little low here. So this is tangent A minus B, 45 minus 240. So I'm going to look at this line here. Tangent A minus B is tangent A minus tangent B over 1 plus tangent A tangent B. Now you guys, you really have to be careful when you're doing the differences. You know, if you have a sum and you're equaling 75, for example, you could do 30 plus 45 or 45 plus 30. Either way, that's 75, right? But when you're looking at a difference, make sure your A and B stay in the right order. This had to be 45 minus 240, not the other way around. So 45 has to be A, 240 has to be B to get what I'm looking for. All right, so let's put in some values. These aren't as pleasant, you guys. They don't always just simplify and work out the right way as the other ones do. So you guys, what's the tangent of 45? Well, that one's nice. It's just a 1, right? So I have 1 minus tangent of 240. So this might not be something you know. So reference it on your unit circle. Remember, tangent is just sine over cosine. So on your unit circle, let's go to the side and find the tangent of 240. All right, so you're down at 240. That's in the third quadrant, and I know you're looking at this, but it's in the third quadrant. Its reference is the pi over 3. So it means that the sine of 240 is negative root 3 over 2. And the cosine of 240 is negative 1/2. They're both negative because we're in the third quadrant. So if you put them over each other to get the tangent of 240, sine over cosine, you get root 3 over 2 over 1/2. Remember, those 2's that are both in the denominator cancel out, and you end up with just root 3. And it is positive. Tangent is positive in the third quadrant. So 1 minus root 3 over, let's see what we get on the bottom, 1 plus, well, the tangent of 45 is 1. Remember, this time you're going to multiply the two tangents. And I just found the tangent of the tangent of 240 is root 3. So here's tan A minus tan B over 1 plus tan A tan B. Now, as far as simplifying this, you don't have to go too far. So I'm going to write this as 1 minus root 3 over, well, you guys, this 1 times root 3, doesn't this just end up being 1 plus root 3? And you guys, we're going to leave it like that. It has a root in the denominator, and I realize that, and Alex realizes that too. But rationalizing the denominator when it's more than just the one root is a lot harder. And you guys, it's the point of the problem is the identity anyway. So this is an exact answer. It's not super, kosher as far as the denominator goes, but this is where you're going to stop. And this is where Alex wants you to stop. All right, so we did a tangent problem. So you guys, one thing about identities is that they work forward and backwards, That's kind of the point. It's an equation. It means that you could go from left to right or right to left, and it's all going to equal. So let's work backwards on a problem or two. It's actually pretty easy to work backwards. It's my favorite way to do it. And you'll see why. Okay, so let me pull up my example. So I've got this example for you. I've got sine 78 cosine 72 plus cosine 78 sine 72. And I'm supposed to just evaluate this exactly. So at first glance, you're like, sine 78, I don't know what that is. That's calculator work. It's not on my unit circle. 72, these are horrible angles to evaluate exactly. But if you look closer, what does this look like? I've got sine, it's like sine A cosine B plus cosine A sine B. Why does that look familiar? You guys, because that's the sign of a sum, right? So isn't sine of A plus B exactly what this says? Sine A cosine B plus cosine A sine B, where A is your 78 degrees and your B is your 72. So you guys, this is just an identity, an expanded side of the identity of sine A plus B. So what you need to do, be able to pick out which identity it comes from. So this was the sign of a sum. Be able to note which one's A, which one's B. And guys, it gave you this side, right? You're gonna put it back to here. So all of this, isn't that just saying sine of 78 plus 72? Yeah, because if you were doing this the other way, if this was your goal, you'd say, oh, this is A, this is B. What would you do? You do sine 78, cosine 72, plus cosine 78, sine 72. So it's just giving you the other side. And you're going to put it back to here. What am I going to do from here? I'm going to add them together, you guys. What is 78 plus 72? Hold on. It's the sine of 150. So 78 plus 72 is 150. So saying this is the same as saying this. And you guys, isn't 150 on my unit circle? So they broke this one up, but you really didn't need to, right? So if I put it back together as 150, that's an easy answer, you guys. That's 1/2, and that's on your unit circle. So can you go from here, pick out an A and B, pick out which identity it's using, send it back to the compressed version of that identity, put your A and B in, either add or subtract, whichever identity it is, and then it's going to be an exact angle there. So I like those, guys. I like to work backwards. It's a lot easier. All right, so let's do one more of those. Let's do a tangent. So I've got tangent of 4 pi over 5 plus tangent of pi over 30 over 1 minus tangent 4 pi over 5 tangent pi over 30. So when you look at this, well, first of all, obviously it's a tangent identity. You guys, those are the only ones with tangent in them. Which one? Is it tangent A plus B or A minus B? And remember, you have these written down so you can tell. You guys, when the plus is on top for the tangent, this is a tangent A plus B identity. What is A? What is B? Well, remember, A comes first. So you guys, A must be 4 pi over 5, and B must be pi over 30. You could turn these into degrees before you add if you want to. I'm just going to add them first and see what happens. So you guys, when I'm adding fractions, they have to have common denominators. So I'm going to rewrite that 4 pi over 5 a little bit. Because you guys, I need to get a 30 on the bottom of that so I can add the two together. So you guys, to get to 30, I would have to multiply by 6 on top and bottom. So I get 24 pi over 30 plus pi over 30. So 24 pi plus 1 pi. Sorry guys. 24 pi plus 1 pi, that's 25 pi over 30. This is my starting angle. That's what they started with before they broke it up. Reduce that as much as possible. And you guys, that's an easy reduction. Just take 5 out of top and bottom and you get 5 pi over 6, which is 150, yes. But remember, 5 pi over 6 is also on your unit circle. What is the tangent at 5 pi over 6? Well, remember, tangent is sine over cosine, so you go to 5 pi over 6. You find that the sine there is positive 1/2. The cosine is negative root 3 over 2. Your 2's cancel out. I'm going to take it way over here, trying not to be too confusing. But you guys, once your 2's cancel out, because they're both the denominator, you get negative 1 over root 3. And you definitely do rationalize a simple one like this, right? Top and bottom by root 3. And you get root 3 over 3, and it is negative still. So don't lose your negative. But you guys, this is all of this just says this. You guys, they're going to break these up into angles, to 2 angles. You're going to have to put them back together and then find the value of that angle on your unit circle. So if you notice, all the problems that we've done so far have ended in a single numbered answer. We've actually been finding the sine, cosine, and tangent of angles and answering them exactly. But if you remember, in 7.1, when we started doing some identities, a lot of times we just use those to like simplify expressions or prove identities, and we never actually solved any angle measures, right? We can use those like this too. And I want to show you one of those. So I'm going to write it, and it's going to look a little bit difficult, but remember, we have these very helpful identities now that are going to help us prove this identity. So in this example, I'm going to use my identities, again, not to solve and get a number, but just to simplify or to prove something is true. So here's what I have to prove on this one. I have sine x times sine of x plus y plus cosine x times cosine of, sorry, I put the parenthesis in the wrong place. Cosine x times cosine of x plus y should somehow equal cosine y. So this is a lot. Let's find out how we can get it down to just this one term, cosine y. Making sure, you guys, we need to be careful here. We do have 2 different angles we're dealing with here. We have x and y. Anything that has an x in it doesn't work identity-wise with something that has a y in it. So, for example, at some point, if I have sine x times sine y, that's not sine squared, right? That's just sine x sine y. If it was sine x times sine x, absolutely. But when you're like multiplying things together like that, like doing a squared or something, they do have to be the same angle input. Okay, so this looks bad, but I'm going to make it look worse. You guys, it's going to get worse before it gets better on this one. You guys, can you spot a couple of sum identities here? Looks to me like sine a plus b and cosine a plus b. Remember, I don't have to have just numbers here. In this case, they're just different variables, but the identities still hold. So what I'm going to do first is I have this sine x. I'm going to replace this term with sine a plus b identity. Now, I know that that identity creates 2 terms. Those terms have to be in parentheses because it still has to be grouped together like this is grouped together. So you guys, when you're going from here to here, please don't lose your parentheses. All right, so what is sine a plus b? That's what I'm looking at here. Isn't that sine a cosine b plus cosine a sine b? So it does look worse. I told you it was going to look worse. And it's going to get even a little worse over here, guys. Because here we have a cosine x, but I'm going to replace cosine x plus y with the sum identity for cosine. So if this is cosine a plus b, that is cosine a cosine B. Remember, if it's a plus here, it's a minus here on cosine. So cosine A, cosine B, minus sine A, sine B. And we're here. And all of this is supposed to somehow equal cosine Y. So you guys, next step. It'll get a tiny bit better on this step. All right, so what we're gonna do, because we have these parentheses, because we need those parentheses, I'm going to distribute this sine term to both of these terms in the parentheses. So that's your next step. You guys, sine x times sine x, those are both x's, so you can put that together as sine squared x. And then this cosine y is just gonna come along. So I have sine squared x cosine y plus, you guys, when I do sine x times cosine x sine y, none of those combine, right? So it's just going to be all three of those terms right next to each other. So I'll have sine x cosine x sine y. Okay, let's distribute this cosine x now. So distribution here. What about this term, guys? Cosine x times cosine x is cosine squared x. And this cosine y is just coming along. What do I have here? Well, I have three terms that don't combine really in any way, so I have that three-term problem again. You guys make sure you know this one's going to have a minus on it. But I'm going to have minus cosine x, sine y. And that still all is supposed to equal cosine y. I lied, it didn't get better on that step. All right, I promise it gets better now. You guys, do I have any like terms here? It's hard to see because they're a little out of order, but this term has sine x, cosine x, and sine y. What does this term have? Well, here's sine x, cosine x, and sine y. You guys, these are like terms. They don't have to be in the exact same order because it's just multiplication, right? So I have plus that term here, and I have minus that term here. What can I do with that? They cancel each other out, guys. And that is where it gets better, right? Because once they cancel each other out, then I have sine squared x cosine y plus cosine squared x cosine y. Again, it's supposed to equal cosine y at some point. And guys, this is where it gets good. You guys, both of these have a common term, right? Both of them have a cosine y. Let's factor that out and see what happens. Hold on, guys. All right, sorry guys, I had to break up a couple of fights out in my house between my boys. But here we are, everything's good now. Where were we? So I have the cosine y in both terms, so I'm going to factor that out. So if I take a cosine y out of both of these terms, what's left over in this term is a sine squared. What's left over in this term is a cosine squared. Remember, you have equals cosine y. What is sine squared plus cosine squared? Well, we have the Pythagorean theorem for that. They're both x's, so it works, right? Sine squared plus cosine squared equals 1, so that's really just 1. And your last line, cosine y equals cosine y. So we're finally there. Now that we're here, let's go through and talk about the rules we use for each line. So from here to here, we use the sum and difference identities. Really just the sum, but I think on your rules it says sum and difference. So you use sum and difference rules to take these and expand them to here. To get to here, we just used algebra. We just distributed that sine x and that cosine x, right? So we just used algebra to get to this line. And honestly, we just used algebra to get to this line also, right? Because this is where we canceled out. This was algebra. To to get to this line, I want to say that's algebra again. It depends on how many steps you guys that you take this in, but I basically used algebra 3 times. So I used it here with the distribution. To get to this line, I used it again by canceling out those. To get to here, I used algebra by factoring out a cosine y. And then to get to here, I used the Pythagorean identity to get me to that last step where I called that 1. And remember, your answers, when you're verifying identities, don't have to look exactly like mine do. There's a lot of different possible ways you could have taken this. So just keep that in mind, work them on paper, make sure you know what rules you're using, and then input all of that as your answer into ALEKS. All right, guys, so that's gonna do it for 7.2. So make sure you ask me any questions if you have problems with this stuff, and I will see you next time.